Welcome to the Chlorine Institute's presentation on preventing non-accident releases, or NARs, by properly securing hydrochloric acid railcar shipments. Hydrochloric acid may also be referred to as HCl throughout this video. Another commonly known name that is used is muriatic acid. During this presentation, you will learn the definition of an NAR, see a review of hydrochloric acid tank car NAR data, and learn tips for preventing hydrochloric acid NARs. The tips provided in this video are applicable for both loaded and residue railcar shipments. What is an NAR? NAR stands for non-accident release. It is a standard metric used by the U.S. Department of Transportation, or DOT, and Transport Canada to measure trends in hazardous materials releases during transportation. NARs single out releases that occur in transit but are not related to an accident. Per U.S. regulatory requirements, all releases of hazardous materials from transportation functions are required to be reported to the DOT by completing and submitting a DOT Form 5800. Transportation functions include, but are not limited to, the transportation or movement of the product in commerce, as well as on-site loading and transloading operations when a carrier employee is present. See Section 49 of the U.S. Code of Federal Regulations, or 49 CFR, Part 171, for more details on reporting requirements. These reports may be completed by the railroad or trucking company while the package is in transit, or by a plant employee if the incident is on-site. The DOT database includes reports for all modes of transportation and all package types, including railcars, trucks, drums, cylinders, totes, etc., and for all phases of transportation, including loaded and residue shipments. It is important to note that, according to DOT definition, a residue shipment is not considered empty. According to DOT's definition, residue is the material remaining in the tank car after its contents have been unloaded to the extent practicable with properly functioning equipment. Empty only refers to containers which have been cleaned of its hazardous contents, purged of hazardous vapors, and no longer contain any amount of product. The Association of American Railroads, or AAR, has certain responsibilities designated by DOT for overseeing the operations and performance of the rail industry, including tank car aspects. Under a task force of its Hazardous Materials Committee, the AAR tracks NAR incident data regularly and develops guidance and resources to aid the industry in reducing these incidents. The data used in AAR's analysis is not to be confused with that which is reported in the DOT database, because AAR only considers incidents that occur while the tank car is in the railroad's possession. For example, the AAR does not consider incidents that occur during on-site loading and unloading at a shipper's or receiver's facility. More details regarding AAR's NAR tracking and guidance may be obtained from their website. Releases that occur during transportation functions are reported differently than releases within plant processes. The primary difference is that for transportation-related releases, there is no reportable quantity threshold, or RQ, as established by the U.S. Environmental Protection Agency, or EPA, which needs to be reached to trigger reporting. Basically, if you can see it, smell it, or hear it during transportation functions, it is an NAR and requires reporting to DOT. NARs can be very expensive. The true cost of an NAR includes a wide variety of expenses, such as medical costs associated with personnel exposures, costs to mitigate the spill, and ongoing costs associated with necessary environmental monitoring after cleanup. Another potential source of cost for tank car spills are railroad fines. Some railroads fine shippers for NARs due to service interruption. Railroad fines may be fixed cost or variable based on the length of the service interruption the railroad incurs. The Federal Railroad Administration, an agency under the DOT that is responsible for rail activity, can assess fines for NARs, which can be costly and sometimes involve lawsuits. Also, as a result of an NAR, your company and the railroad can suffer a damaged public perception. Another real cost that is difficult to quantify. The Chlorine Institute, also referred to as CI or the Institute throughout this presentation, uses the DOT 5800 reported NARs to monitor the performance of the industry's efforts in reducing preventable hydrochloric acid releases. CI's Transportation Committee sets long-term and incremental goals in an effort to reduce incidents involving bulk packages for all of the chemicals covered under the Institute's mission, including chlorine, caustic, and hydrochloric acid. While the long-term goal is to achieve zero releases in transportation, this committee's current incremental goal is to address at least the top 2 causes for each product and mode by developing programs and practices to prevent future transportation incidents and ultimately achieve zero releases in transportation. This chart shows the total number of the hydrochloric acid railcar incidents from 2011 through 2023. A lot of work has gone into improving railcar equipment and best practices for handling hydrochloric acid tank cars over the years, which is reflected in this downward annual trend. This next chart shows you the cumulative tally of incident causes or leak sources over the same period. The causes reflected as blue bars are those considered to be non-accidental releases, and those reflected as gray bars are releases due to derailments or accidents. You'll see that human error involving the proper securement of service equipment, including the liquid line, fill hole, air inlet, and pressure relief device, is the largest cause of leaks. Collectively, releases due to human error or equipment failures, which are considered NARs, attribute to over 80% of all hydrochloric acid railcar incidents reported to DOT during 2011 to 2023. A large portion of those NARs are related to the improper securement of service equipment, which highlights the biggest opportunity for reducing preventable leaks on caustic railcars, which is the focus of this video. After this video is published, you may periodically check CI's bookstore page to find updated incident data. It is important to remember that the party who prepares and offers a hydrochloric acid tank car for transport is considered the shipper of record. This includes the unloading location that prepares a residue car for a return shipment back to the supplier. It is the shipper of record's responsibility to ensure that the tank car is properly secured. If there is a leak during the movement of the car, the shipper of record will be held responsible for the incident. Here are some tips for securing hydrochloric acid railcars that will ultimately lead to preventing hydrochloric acid NARs. A checklist is a valuable tool to help standardize the process and to make sure steps are not omitted. The Chlorine Institute has developed checklists and various guidance that can be made available to users. CI resources will be discussed towards the end of this presentation. Be sure your procedures and checklists include the following critical tips for securing hydrochloric acid railcars. The first thing you should do before closing up a loaded car is to confirm the quantity of the product that has been loaded. This can be done by verifying the weight indicated on the scale and by visual inspection through the fill hole in conjunction with gauging the tank car using strapping charts or outage tables. Verifying the quantity will ensure that the car has not been overloaded during the loading process. This will help reduce the chances of an NAR during shipment. An additional step prior to securing a loaded car for transport is to perform a conductivity test, per company procedure, to determine the condition of the car's rubber lining. This will help detect a possible issue with the lining. This is not to be confused with spark testing, which is another method for detecting lining issues when the car is empty prior to loading. You can find additional instructions on conductivity testing in CI's pamphlet 98. The next practice for reducing NARs is to inspect and clean all of the gaskets and fasteners on the fittings, including bolts and washers. Debris, Rust or damaged parts can create extra torque before sealing, which gives the illusion that the fitting is secured tightly. Here is a picture that shows the bottom of a fitting with debris on the bolt threads and an old, warped gasket. Old or damaged gaskets and fasteners should be replaced with the same that was previously installed. Check the materials of construction and manufacturing stamps on items or in tank car drawings to ensure that the same equipment is used as replacements. If preparing a car for a return shipment, the supplier should be contacted if any parts require replacing. For rubber-lined fittings that do not have gaskets installed, inspect the lined flanged face to ensure the rubber lining is free from excessive cracks or other damage that could potentially result in an NAR. If damage is found, repair the lining as needed per company procedure. A post-load leak check could determine if further action is needed. Once all fasteners and gaskets are in good condition, all fasteners on fittings should be tightened using the proper crisscross pattern torquing method. Sample torquing patterns are shown here for fittings with 6, 8, or 10 bolts, but the concept is similar for fittings with a different number of fasteners. All fasteners should be tightened so they remain secured under normal conditions through the entire duration of shipment. Tank cars with protective housings may make tightening fasteners more difficult due to given clearances. If you have difficulty tightening fasteners, contact your supplier for recommended tightening practices. The use of segmented washers is recommended to help ensure effective torque and securement of fasteners. If segmented washers are installed on the car and need to be replaced, then segmented washers should be used as replacements. For unloaders preparing a car for a return shipment, the supplier should be contacted if washers require replacing. It is important to ensure that the tank car's pressure relief device is closed and properly secured. Either of two types of relief devices may be installed on the railcar: a pressure relief valve or a rupture disc, as shown here. Two types of rupture discs are acceptable for use in hydrochloric acid service. An example of a polyphenylene sulfide, such as Riton, rupture disc with optional Teflon lining is shown on the top. An example of a graphite rupture disc, which is lined on the bottom side with Viton and is coated with green Teflon, is shown on the bottom. While both types of pressure relief devices are acceptable for hydrochloric acid service, it is recommended that a reclosing safety relief device is used, such as a spring-loaded pressure relief valve, to help reduce the likelihood and size of an NAR. Pressure relief devices on hydrochloric acid tank cars are typically rated at 165 psig, but some cars may have devices rated at 75 psig. Both ratings are acceptable. However, a higher rating of 165 psig will help reduce the likelihood of an unintentional product release from the relief device due to pressure surges in the car while in transport. If the car is equipped with a rupture disc as opposed to a pressure relief valve, careful inspection of the rupture disc assembly must be done prior to offering the railcar for transportation to ensure damage or defects are not present that could alter the intended operation of the device. In general, this can be achieved by cutting or removing the cable seal if present, removing the threaded cap, inspecting both sides of the rupture disc, reapplying and tightening the threaded cap, hand tight, and installing a new cable seal. Throughout the inspection process, look for cracks, signs of excessive wear, corrosion, missing components, and other evidence of altered condition of the device. A damaged or corroded rupture disc should be replaced with a new disc, which can be obtained from your supplier. Different style rupture disc assemblies may require different inspection and assembly steps. Note that the removal of the rupture disc is not required on tank cars that contain residue per DOT regulations. Not removing the rupture disc and instead leaving it in place during inspection helps prevent errors in reassembly and therefore reduces the chances of an NAR. It is recommended that you refer to the DOT regulations in 49 CFR Part 173 and consult your supplier for more detailed requirements and instruction on inspecting rupture disc assemblies. After inspection, it is crucial to ensure proper assembly and securement of the rupture disc assembly. Be sure the disc is installed with proper flow direction. Original equipment manufacturers, or OEMs, provide instructions to ensure proper orientation of the disc and housing assembly. You may also conduct a pressure leak check to ensure proper functioning of the rupture disc, in addition to visually inspecting the rupture disc. Here are sample rupture disc assembly drawings and assembly instructions. 2 rupture disc sizes and several styles are acceptable. Any replacement parts should be the same as what was installed. Unloaders should contact their supplier if a new rupture disc is needed. After all fasteners have been properly tightened, verify that all openings to the railcar are closed and secure. This includes closing the valves after the car is disconnected from the loading or unloading system, installing and fastening the fill hole cover, and fastening all other openings to the tank car. This even includes verifying that fittings not even used during the process are closed and properly secured. All hydrochloric acid tank cars are lined with a rubber lining to protect the steel tank. On most cars, this rubber lining extends to cover the surface of the fittings that will be exposed to the acid. When securing the fittings, natural rubber tends to flow outwards of the connection faces, also known as creep or cold flow. If time is not allowed for the rubber to relax to its final position, it can create the illusion that the fittings are secured tighter than they actually are. This behavior is more typical with newer rubber. To ensure fittings are properly secured, it is recommended to tighten their fasteners multiple times until relaxation of the rubber no longer appears to be present. If time lapses before shipment, a final check should be made to ensure all valves and fittings are still fastened tightly. To address the issue of rubber creep, suppliers have developed alternative materials that can be used to coat and line fitting surfaces. Materials currently being tested include ultra-high molecular weight polyethylene or UHMWPE flange faces, polytetrafluoroethylene or PTFE coating. A well-known PTFE product is Teflon by Chemours, polyvinylidene fluoride or PVDF coating. A well-known PVDF product is Kynar by Arkema. After all fittings have been closed and secured, it is recommended that the railcar and fittings be washed down with water to remove spilled product. Doing so will provide evidence that the car was clean and secure prior to shipment. This is particularly beneficial when en route tampering of the car is suspected. Cleaning acid spillage will also help prevent corrosion of the car's steel parts. However, be aware that some older cars may have existing stains that cannot be cleaned away. A crucial step in the securement process is to check all fittings for leaks prior to shipment. For hydrochloric acid tank cars, commonly used methods are the use of aqua ammonia solution or bubble leak solution to detect any leaks. Both of these leak check methods require the car to be under pressure, typically 25 to 30 psig, to be effective in detecting leaks. This pressure should be released prior to shipment. One general tip for leak checking is to wait as long as possible before doing a final leak check prior to the railcar being offered for shipment. A long dwell time will allow very small leaks to develop and become detectable. The longer the dwell time, the better. Some shippers let the car sit up to 24 hours prior to shipment. If an aqua ammonia solution is used for leak checking, there are some important tips to keep in mind. It is recommended to use a 5 to 30% aqua ammonia solution. Be sure the solution is within this range because a stronger solution can accelerate corrosion if acid is present, and a weaker solution won't be effective in detecting a leak. When using lower concentrations, such as the 5 to 10% range, it is recommended to conduct frequent checks to ensure the solution strength has not degraded below 5%. A common dispersal method for the aqua ammonia solution is to use a squeeze bottle with an internal tube that only extends into the vapor space of the bottle. If the bottle you have has an internal tube that extends into the liquid space, it is suggested to either remove the tube or cut the tube to a length that extends only into the vapor space. Many different bottle styles are acceptable. It is very important not to use a liquid stream when performing the aqua ammonia leak check, because if a leak is present, the liquid can cause corrosion and make the leak worse. Using a bubble leak solution is a slightly different application method than using aqua ammonia. In general, the application of the bubble leak solution can be applied in any suitable way. Be sure to reference and follow your company's bubble leak test procedures. There are many acceptable commercial-grade solutions on the market to use for bubble leak testing. Here are some products currently used in the industry. After all fittings have been checked for leaks, one of the final steps to help reduce NARs is to reduce the pressure in the car as low as possible before shipping. For hydrochloric acid shipments, zero pressure in the car is recommended. Added pressure in the car increases the vapor pressure. If too much pressure builds up in the car, the safety relief device could potentially release during transport, or a leak can occur through an unsecured fitting. It is less likely that an NAR will occur if there is zero pressure in the car. If a protective housing is not in place to cover the fittings, the valve handles must be removed so the valves are not accidentally opened during transit. Handles are typically attached somewhere to the valve by a chain, so the handle is not lost during transit. Handles can also be removed even if a protective housing is in place. Safety and security go hand in hand. Before a hydrochloric acid railcar leaves the plant, there are a few tamper-evident measures commonly used to avoid tampering and other suspicious activity during the shipment. Protective housings have become a requirement for newer hydrochloric acid cars and are a permanent feature on the car. Most fittings will often be located within this housing for protection, but the protective housing may or may not include a cover. For added security, the housing and fittings are often locked with cable seals. Suppliers who use cable seals often provide new cable seals for the return shipment. If a protective housing is not in place, some shippers use tamper-evident bags to deter unauthorized access to the car's fittings. These bags are designed for reuse on the return shipment. Before offering the railcar for shipment, it is also recommended to take pictures of secured fittings and tamper-evident measures. These pictures provide confirmation of proper securement before shipment, which is particularly helpful when fittings are found to be loose during transit due to tampering rather than improper securement. Shippers can avoid violations and fines if they can provide this evidence. And now, one final and very important comment. If for some reason the railcar cannot be sealed properly and leaks continue to be detected, it is critical that you do not ship the car. If you are offering a return shipment, mark the location of the leak and contact your supplier immediately. Your supplier will work with you to address the leak and properly prepare the car for return shipment. The Chlorine Institute offers a variety of pamphlets and other information that addresses the safe handling of hydrochloric acid. Pamphlet 98, Recommended Practices for Handling Hydrochloric Acid Tank Cars, and the HCL-Video, Safe Handling of Hydrochloric Acid, provide general guidance on handling hydrochloric acid and loading and unloading steps. Pamphlet 98 also includes a sample checklist that may be used for preparing railcars for shipment. These pamphlets also reference relevant U.S. and Canadian hazardous materials transportation regulations. Guidelines for responding to HCl tank car emergencies can also be found in Pamphlet 98. Chlorine Institute publications are available for download from the Chlorine Institute's website at www.chlorineinstitute.org. As mentioned earlier in the presentation, additional NAR guidance may be found on the AAR's website at www.aar.org/NAR.